All right, we're going to do a real quick review of Chapter 9. I think you're going to find that there's not a whole lot to it except for the vector part. On 9:1 through several sections, it was all about transformations. The first transformation that we started with was reflections, and if you'll look at your study guide, I am very specific on the study guide as far as what you do for the different reflections. So if I were to sum it up, I would say if you are going over the x-axis, you literally would just take the opposite of the y. If the y is positive, you make it negative. If it's negative, you make it positive. If it's over the x-axis, then, or over the y-axis, then you take the opposite of the x. If it's over the origin, you take the opposite of both of them. If it's over the y equals x, then the x and the y just switch places. What was the y becomes the x, what was the x becomes the y. If you look on page 1 of your study guide, all of that is laid out for you, and there's an example below it, okay? On page 2 of the study guide, it is all about translations. Now with translations, that means you're literally going to slide it or just move it right and left, which affects the x, or you're going to move it up and down, which affects the y. So on translations or slides, what they're going to do is they're going to tell you, they might present it with just 2 right and 4 up. So what you would do is you would take the, I don't need all of those, but you would take the x and you would add 2 to the x values, and you would have add 4 to the y values. You would do that for every x you had and every y you had. If you're going right or left, it affects the x. If you're going up or down, it affects the y. If you go to the left, you're going to add a negative 2. Like if you went 2 to the left, you would add negative 2 to the x. If you went 4 down, you would add negative 4 to the y. So that's what you see on page 2 of your study guide. It's very much laid out for you again, and there's an example of it at the bottom. Page 3 of your study guide has to do with rotations. Now, rotations are the one that you are going to use a rotation matrix for. So literally, we're not going to use the protractor, which is the old-fashioned way to do it. So your rotation matrices are on page 508 in your book. You need to have them put into your calculator so you don't have to memorize them and know whether they're A, B, and C or G, H, and I, however you've got them put in there. You literally are going to multiply, if you have these particular matrices, let's say you have this triangle, negative 2, 1, you have 3, 2, and you have negative 4, 5. The very first thing you're going to do is you're going to make a matrix out of it by taking the x and putting it on top of the y. You're going to put that in your calculator. And then depending on the rotation that they want you to use, you're going to multiply this by your matrix. The resulting matrix would be what your new transformation is, okay? There's one down at the bottom of page 3. Literally, they're taking this and they are moving it, rotating it 180 degrees counterclockwise. Under step 2, you see that 180 degree rotation matrix multiplied by your x and your y's, and the resulting matrix will give you basically your A prime, your B prime, and your C prime, okay? That's very much done out for you, shouldn't be a whole lot to it. Page 4 is all about dilations. Dilations is making something bigger or something smaller. So if it's greater than 1, you're going to be enlarging your graph. If it's going to be less than 1, you're going to reduce it. And if it's equal to, they're going to be exactly the same. So, like for instance, if I wanted to do -2, 4, let's call that A, -3, 5, and maybe 7, 0. And I wanted to dilate these by a scale factor, which we typically call R. So R equals, let's say, 2. That would literally mean all I would do is multiply everything by 2. So A prime would be -4, 8. B prime would be -6, 10. And C prime would be 14, 0. Obviously, then you'd have to be able to graph both of those on a coordinate plane. So that is 9, 5. The only part that might trip you up a little bit are the vectors, which is 9, 6. And a vector is a quantity that has both magnitude, which is length to it, and direction to it. If you look at page 5 on your study guide, a standard position of a matrix has the base or the tail there, and let's say it goes to the point 2, 4. Okay? So if I have that, and that would be the component form of that, is literally that. So it's the difference from 0 to 2, that's going to be your x, and the difference from 0 to 4, that's going to be your y. So that's 2, 4. That's the component form of your vector. If you wanted to know the distance of your vector, you literally could do Pythagorean theorem, or you take your x and you square it, and your y and you square it, and then take the square root of it. So that's the square root of 4 plus, if you will, that's 16. So it's the square root of 20, which is 2 on the square root of 5. So that's your magnitude of that. If you were trying to find your direction of that, I know that this is 4 and this is 2. And I go back to trig. I want to know the magnitude or the difference from my x-axis to my graph there. Now, there is another, I think, no, I needed to do the distance. Well, I could do it that way. I could do the magnitude that way. I'm going to show you another way to do the magnitude as well. But this right here will allow me to find that angle. So the tangent of theta is 4 over 2, opposite over adjacent. I'm going to have to use my calculator, make sure it's in degrees, and I'm going to use inverse tangent of 2, and I'm going to get 63 degrees, which is going to be this angle right here. Okay? Now, another way to find the distance is to measure tip to tail. So I've got this way. The other way is use the distance formula, which is the square root of, if you will, the tip is 2, 4, so I'd have to take it to this. So it's 4 minus 0 squared plus 2 minus 0 squared. That's the difference in the y's plus the difference in the x's, which is going to give me 16 plus 4, which is going to give me the same thing I had right there, or 2 on the square root of 5. It can be done both ways. You also learned how to do it when the center is not on the origin. So let's do one like that. Let me see if there's one in the review work that has that. Let me look at number 35. Number 35 looks like this. You have A is at -3, negative 2. So this is A. And then B is at 0, 2. And that right, it goes like this. Okay, this is your tip, this is your tail. So if you wanted to, you could square it out, and you could do the difference in the x and square it and use the Pythagorean theorem. Or you can use the distance here and just go, it's the square root. Now remember, tip to tail. So 0 minus a negative 3 squared plus 2 minus a negative 2 squared. So that's going to give me 9 plus, and that's going to be 4 squared, which is going to be 16. So that's going to give me the square root of 25. So the magnitude of this is going to be 5. That's going to be the distance from there to there. Direction is a little bit trickier. I'm literally going to take this and I'm going to transpose it up like this. Okay, so I've taken this and I've moved it here. Now, the difference in these two, from negative 2 to positive 2, is 4. So that the distance there is 4. From negative 3 to 0 is 3. So now I do the tangent here. The tangent of theta is 4 over 3. So I need to do the inverse tangent of 4 divided by 3. And that's going to give me a direction of 53 degrees. Okay? Now, the other thing that they do is sometimes they'll take the vectors and they'll do translations on them. So, on the bottom of page 6, there's a problem that says vectors can be used in doing two translations at once. First, add the two vectors together. So you've got B, C, and D. So B is at negative 1, 2. C is at 3, 4. D is at negative 4, negative 9. And it says do these two translations. 4, 2, this is the vector V. And the vector X is negative 2, negative 4. Now this basically, whoops, I need it in component form. This basically means to the x I'm going to add 4, to the y I'm going to add 2, to the x I'm going to add negative 1 to negative 2, and 4 to negative 2. So I could do this one, and then get an answer, and then do this one. Or I can put these two things together and say 4 plus negative 2 is positive 2. 2 plus negative 4 is negative 2. So what this means is, to the x, I'm going to add 2, and to the y, I'm going to add a negative 2. And I will have done my translation. Okay, so vectors can be used for translations. So what I want you to do is, for homework, okay, which you're going to have all the stuff in your packet to check this, I want you to do page 513 through page 516, and I want you to do 10 through 10 through 46 even. Now, when it says use a matrix, the only one that you have to use a matrix for is going to be your rotation. Okay?